So where do we use differentiation in microeconomics? Well, differentiation is very often used when you have to calculate the marginal product. So for example, if the production function is given and from there you need to calculate the marginal product of labor or the marginal product of capital, you would be using differentiation. For the marginal product of labor, you would differentiate the production function with respect to labor, and for marginal product of capital, you would be calculating the derivative of the production function with respect to the capital. Two more other important marginal concepts that will come handy during calculation questions is how to calculate marginal revenue and marginal cost. And marginal revenue, by definition, is the derivative of the total revenue with respect to the quantity, and the marginal cost is the derivative of the total cost with respect to quantity. So let's look at some practical examples. Suppose the production function is given by Q equals 2K plus 5L. So I know that my production function is 2K plus 5L. What is the marginal product of capital? So the question is the marginal product of capital when 5 units of capital, so K is 5, and 10 units of labor, so L is 10, are employed. What is the marginal product of labor? So we've got two questions. We need to calculate first the marginal product of capital, and then we need to calculate the marginal product of labor. So recall the definition. The marginal product of capital is the derivative of the production function with respect to the capital. So in this case, I'm only interested in the change in capital. I'm not interested in the change in labor. So labor is held constant, and constant's derivative is always 0. So when I come back to the production function, I'm only interested in this term because that term becomes 0 when I'm differentiating it, because it will be constant. So what's the derivative of 2K? Is 2. See, importance here, doesn't matter if capital is 5 and labor is 10, the marginal product of capital will always be 2, because after differentiation, the variable K disappears. So it's independent of individual capitals and labors applied. Similarly, the marginal product of labor is the derivative of the production function, but now with respect to the labor. So now K is held constant. I should have written here that labor is constant. And because K is now constant, the first term in the production function will become constant, because I'm only interested in the change with respect to labor. So constant's derivative is 0. 5L's derivative is 5. And similarly, as to the marginal product of capital, for this particular production function, the marginal product of labor is independent of how many labor I'm applying. It's always going to be 5. Now that's not always the case, because you can have some production functions where after differentiation the variables are still present. So let's look at one such example. So suppose the production function is given by Q equals K to the 0.5 times L to the 0.5. So this is a very different production function, because here now capital and labor are multiplied while before they were added. What is the marginal product of capital? So again, marginal product of capital is the question. Then 25 units of capital, so K equals 25, and 9 units of labor are employed. What is the marginal product of labor? So again, we have got two questions. First, the marginal product of capital, and second, the marginal product of labor. So again, what is the definition to calculate marginal product of capital? So MPK, by definition, is the derivative of the production function with respect to capital.
Now, what is our production function in this specific case? Q equals K to the 0.5 L to the 0.5. Now, the important thing is here, when we're differentiating with respect to K, or when we're looking for the marginal product of capital, we keep labor constant. Now, what is that constant value? Well, that's been given to us, that's exactly 9. So I can rewrite my production function as K to the 0.5 times 9 to the 0.5. Now again, I remember that 0.5 is a half, so 9 to the 0.5 is the same as 9 to the half. And I again remember that the half power is the root, the square root of 9, which is 3. So this exact production function is 3 times K to the 0.5. Now that looks a little bit simpler, so let's differentiate it. So constant stays, bring the power down, so that will be 3 times 0.5, and lower the power by 1. By now you should know that 0.5 take away 1 gives me minus 0.5. So that will be 1.5 times K to the minus 0.5. Now this is the marginal product of capital function because it still depends on K. But the question was, what is the value of the marginal product of capital when this capital and this labor is applied? So there is one more step in here that we need to do, and that is substitute the actual value of capital back into this formula. So our final marginal product of capital will be 1.5 times 25 to the minus 0.5. And if you want to be lazy, you can just pick up the calculator and put it all in. 1.5 times 25 to the power of minus 0.5. And the answer will be 3 over 10, which is exactly 0.3 after you press the SD button. Similarly, what happens in the case of marginal product of labor? Well, the definition is differentiate the production function with respect to labor while capital is held constant. Now my capital is constant, and in this case the capital is now 25 because I've been given that value. So what does the actual production function look like as a function of labor only? So Q then now will be 25 to the 0.5 times L to the 0.5. Similarly as before, the 0.5 power is the root, so this is basically root 25 times L to the 0.5, which is 5 times L to the 0.5. So to find the marginal product of labor, all I need to do now is differentiate 5 L to the 0.5. So again, the differentiation rules. Keep the constant multiplier, bring the power down, and lower the power by 1. But same case scenario as above, the 0.5 will become minus 0.5 after taking 1 away from it. So 5 times 0.5 gives you 2.5 L to the minus 0.5. Again, this is the marginal product of labor function because it still depends on L. But the question was, what are these marginal products in the given specific values of capital and labor? So we need to substitute back L into the function. So the final answer is 2.5 times 9 to the minus 0.5. And again, use the calculator. 2.5 times 9 to the power of minus 0.5, and that gives you 5 over 6, which is not an exact function, is 0.8333 recurring, but we can round it to 0.8 to 1 decimal places. So the key is here, when you're calculating the marginal product of capital, you keep labor constant. And usually that labor is given to you, so you can just substitute that back into the original production function. So you will be able to reduce the production function just as the function of capital. Then differentiate it and substitute back the given value of capital. Same for the marginal product of labor, because the marginal product of labor is the change in labor when capital is constant. So again, substitute back the constant value of that capital into the original production function, so you can reduce the production function as a function of labor only, then carry out the differentiation and then substitute back the actual labor value to find the marginal product of labor for producing 9 units of good.
So that was the marginal product of labor and the marginal product of capital applied to 2 different types of production functions. Let's move on and see how we can calculate marginal cost. So given a cost function, CQ equals 150 plus 12Q plus 5Q squared. What is the marginal cost function? So the marginal cost function, by definition, is the derivative of the total cost with respect to the quantity. Now, this notation of C bracket Q is just telling you that the cost function is a function of Q, is a function of quantity, and then it's telling you the exact function of the quantity. But this cost function is actually exactly the same as the total cost would be, because remember, that's the fixed cost and this is the variable cost. So this is actually the total cost function. So you don't always use TC for the total cost, you sometimes just use C bracket Q. But what it tells me that I need to find the marginal cost is I have to differentiate that cost function with respect to the quantity. So this is a cost function of 3 terms. Let's go about it and differentiate it term by term. The first term is a constant. Constant's derivative is 0. Well, that's nice and easy. I don't have to write anything down. The second term is 12Q. Well, now Q is exactly the same here as X would be. So when I'm differentiating with respect to Q, 12Q's derivative will be just 12. Remember, if it was 12X, it would become 12, but because now it's 12Q, it also becomes 12. And the last term is 5Q squared. Now that's a power. All I've done, I've just changed X for Q, but the rule is the same. Bring the power down, so 2 times 5 makes it 10, and lower the power by 1. So 2 minus 1 gives it 1, so it will be Q to the power of 1, but we don't write out the power of 1. And that is the answer, because the question was, what is the marginal cost function? And this is a function because I have got the variable Q in here. So the marginal cost function will be 12 plus 10Q. One more example on the marginal cost. So for the cost function of CQ being equal 25 plus 3Q plus 4Q squared, what is the marginal cost of producing 5 units of output? So I need to do the marginal cost, but now for a special case of Q units of output being equal to 5. So first of all, I need to calculate the marginal cost function, just like in the previous example, and then substitute the Q's value back into being 5. So what is the derivative of this function with respect to Q, which is my marginal cost? So 25 is a constant. Constant's derivative is 0. 3Q's derivative is 3 plus power. Bring the power down, that 4 times 2 makes it 8, and Q squared becomes Q. So that is the function But now I need to know the exact marginal cost for 5 units of output. So what I need to do now, I need to substitute the Q for 5 in the marginal cost. So 3 plus 8 times 5. Well, 8 times 5 is 40. 40 plus 3 gives me 43. So the marginal cost of producing 5 units of output is 43. Now let's look at some more complicated questions. Let's look at how to work out profit and profit maximizing level of output for a perfect competition. Now, when we're talking about perfect competition, there are a few things that we need to remember. Well, price is equal to the marginal revenue, which is also equal to the marginal cost. And also, what is profit? Well, profit is the difference between total revenue and the total cost. And total revenue can be calculated by price times quantity. And the total cost we can calculate by substituting the quantity into the cost function. Now observe that I've introduced something called Q star in here. Now Q star is the profit maximizing level of output. So we don't going to just substitute any odd Q into total revenue and total cost. We need to calculate a specific profit maximizing level of output to be able to calculate the maximum profit. So how are we going to go about that? Let's look at a practical example. You are a manager of a firm that sells its product in a competitive market at a price of 50. Your firm's cost function is C equals 20 plus 5Q squared. What is the profit maximizing output for your firm? Now there's a lot of things going on in here, but let's pick the question into parts and find out what are the most important things. Well, one of the most important things in here is that I am working in a competitive market. Competitive market means that I am a price taker. Okay? I have got no influence over the price. I have to take the market price, which means that I can only manipulate my own costs. So, in a perfect competition, one of the first conditions that you always have to remember is that the marginal cost have to be equal to the price. That's how I can start going on about the questions. The other thing, what other information do I have there? Well, a price is 50, so I know that P has to be equal to 50, and I also know the cost function is being 20 plus 5Q squared. Now I have got everything to be able to calculate the profit maximizing level of output. How? Well, there's the cost function, so I can calculate the marginal cost through differentiation. So this is my total cost function. So how am I going to differentiate this? Well, 20's derivative is 0 and 5Q squared derivative is 10Q. And this is my marginal cost, which is 10Q, and that has to be equal to my price because I'm in a perfectly competitive market, which means that this 10Q, my marginal cost, have to be equal to my price, which is 50. Well, that's simple enough. If 10Q is 50, then Q have to be equal to 5. And that is my profit maximizing level of output. And that is the answer to this question. Let's take it one step further and calculate the maximum profit. So you are a manager in a perfectly competitive market. The price in your market is 16. Your total cost curve is CQ equals 15 plus 2Q plus 0.5Q squared. What level of profits will you make in the short run? Okay, again, information. Perfectly competitive market. So the marginal cost have to be equal to the price. The price is given to me as 16 and the cost function is given to me as 15 plus 2Q plus 0.5Q squared. And the question is the profit. So profit is equal to total revenue minus total cost. For that, I need to calculate the total revenue first, and then I need to calculate the total cost. So the total revenue, remember, was price times Q star, and the total cost was the cost function at this Q star level. So first of all, I need to find this Q star, and this Q star was the profit maximizing level of output. How were we able to calculate that? While using this condition of working in the perfectly competitive market. So first I need to calculate the marginal cost, which is the derivative of the total cost with respect to quantity. So I'm going to have to differentiate this function with respect to Q. So 15's derivative is 0, 2Q's derivative is 2, 0.5 Q square's derivative. Now, it's a power function, so bring the power down. 2 times half is just 1, and Q squared becomes Q because I'm lowering the power by 1. So the marginal cost is 2 plus Q. But that marginal cost have to be equal to the price because I'm working in a perfectly competitive market. So this 2 plus Q have to be equal to 16. That's simple, because then that means that Q have to be 14. So I found the profit maximizing level of output. But that's not the end of the question, because I need the exact profit. So now I need to calculate the total revenue, which will be price, which was 16 times 14, which is 16 times 14 gives me 224. And I also need the total cost, which was the cost function at this particular level of output. So what I need to do now, pick up this 14 and substitute that back into the cost function. So that will be 15 plus 2 times 14 plus 0.5 times 14 squared. Again, bring the calculator to help. 15 plus 2 times 14 plus 0.5 times 14 squared. That's going to give me 141. And then the profit will be the total revenue, which was 224, minus the total cost, which was 141. So 224 minus 141, and that gives me 83. So the profit, the maximum profit I can get is £83. Now let's look at one more of this profit maximization question, because this is involved quite a few different steps in the calculation. So you are the manager of a firm that sells its product in a competitive market. So again, as soon as you hear competitive market, you need to remember that the marginal cost always have to be equal to the price. At a price of 60, so again, we know the price in the market. Your firm's cost function, handy, so we'll be able to calculate the marginal cost. And that is 10 plus 5Q squared. And what is your firm's maximum profit? So again, the profit is the question. So, to be able to calculate the profit, we need the total revenue and the total cost. Remember, the total revenue was price times the profit maximizing output, and the total cost was the cost at this profit maximizing level of output. So to be able to calculate the profit, we need that profit maximizing level of output. Where did you find it from? The condition of working in a perfectly competitive market. So first, I need to calculate the marginal cost. That is the derivative of the cost with respect to the quantity. So that's my cost function, simpler than the previous one. So 10 plus 5Q squared. What's the derivative of this? 10 is a constant, its derivative is 0. 5Q squared is a power function, so bring the power down. 5 times 2 gives you 10, and Q squared derivative just going to be Q, because 2 minus 1 makes it 1. So that's a very simple marginal cost function, 10Q. That has to be equal to the price. So 10Q have to be equal to the price, which is 60. So Q going to be 6, and that is my profit maximizing level of output. Now I've got this profit maximizing level of output, I can calculate the total revenue and I can calculate the total cost. So the total revenue will be price, which was 60, times 6, so that gives me 360. The total cost is, remember, the cost function at this particular level, so I need to substitute the 6 into the cost function, so that is 10 plus 5 times 6 squared. Again, pick out the calculator to save some time. That gives me 190, and then the profit is just that 360 minus 190. Which is 170, so the profit is 170. Now, because these profit maximizing questions are quite long, I think it's a good idea for us to summarize the steps in the question. So how many steps and in what sequence should we carry out these calculations? So first of all, when you are trying to find either the profit maximizing level of output or the maximum profit, the first step always going to be to calculate the marginal cost function. So you would need to differentiate the cost function with respect to the quantity as the first step in every of these type of calculations. And then in step 2, you need to use the condition of working in a perfectly competitive market of marginal cost being equal to price to find the Q star, which is the profit maximizing level of output. Now, if the profit maximizing level of output was the question, then you can stop here because you already found that output. That would be your Q star. But if it's the maximum profit that is the question, you have to move on. So the third step would be calculating the total revenue by multiplying the price and Q star together. The fourth step would be calculating the total cost. Remember, all you need to do here is go back to your original cost function and substitute Q star into this function. And the last step is quite simple. To calculate the profit, you need to find the difference between the total revenue and the total cost. So you just take away those two quantities that you found in step 3 and step 4. You sometimes have to calculate the maximum profit of a monopolist. Now the monopolist works similarly, but instead of the cost, now you can manipulate the revenue, because remember, the monopolist is a price setter. It's not a price taker, it's setting the price. So it has got that privilege to saying, okay, I want to maximize my profit, so I'm going to do so by setting the price. So in that, instead of the cost function, you would be working with the revenue function. But the calculations are very, very similar. So I'm pretty sure you will be able to work it out yourself. But if not, or if you're having any problems, don't forget to get in touch. My contact details are on the slide.